Good morning and welcome to this public meeting of the Consumer Product Safety Commission. At this meeting, the CPSC staff will brief the Commission on a draft notice of proposed rulemaking to establish a mandatory safety standard for lithium-ion batteries used in micromobility devices and for electrical systems for micromobility products containing such batteries. Before we start, I just want to take a moment to acknowledge that this is going to be my last public meeting in the chair seat. Next week, I intend to step down as chair of the CPSC, and by operation of law, our newly elected vice chair, Commissioner Peter Feldman, will become acting chair. I look forward to working with him and my fellow colleagues from another seat on the dais, and I hope that you'll join me in congratulating him in anticipation of his new role. It's been a privilege to lead the CPSC for the last 3 years, and I'm very proud of this agency and what it's been able to do and accomplish in this period. I want to personally thank my fellow commissioners and their staffs, along with the CPSC staff, for their professionalism and dedication to this agency and its safety mission. But in particular, I want to thank my staff and senior leadership for all that they've done to support not only me, but the agency during this time. They have worked hard and sweated and done more, gone above and beyond to be able to help me and to help the mission of the agency, and I can't be more thankful to them. Many of you have experienced leadership changes previously, and I'm confident that just as in past transitions, you're going to remain steadfast in your work for consumers. Commissioner Feldman and I will be working with our senior management team to ensure a smooth transition, and I look forward to continuing our progress together.
Mr. Chairman, may I say a few words?
Sure.
Thank you. First, thank you for those kind words. I am honored and grateful for the trust and confidence that my colleagues have shown in electing me vice chair. This is an opportunity to continue my public service at CPSC, and the new role is both humbling and exciting. I'm committed to working alongside all of you to advance our mission and protect the health and safety of American families. Mr. Chairman, in particular, I want to acknowledge and thank you for your commitment to a smooth transition. That's equally true of your staff, all of whom have been so generous with their time throughout this whole process. I've enjoyed working with you over the past few years and look forward to continuing that relationship. I'm going to have more to say in the coming days, but I do want to thank you for your support and your leadership.
Thank you. Now let's turn back to the main show, the briefing. Lithium-ion batteries safety has been a priority for me. We're all well aware of the devastation that can be caused by fires ignited in a thermal runaway. These fires are particularly frightening and dangerous. They burn extremely hot and can spread rapidly through homes and apartment buildings. Fires tied to e-bikes and scooters powered by lithium-ion batteries have resulted in far too many avoidable deaths and injuries. I look forward to hearing from staff about how a mandatory safety rule could improve the safety of these products and prevent devastating fires in the future. In a moment, I'm going to turn this briefing over to staff so that they can brief us. Once they've completed the briefing, each commissioner will have 10 minutes to ask questions of staff with multiple rounds if necessary. As a reminder, if you have questions that address the agency's legal authority or other legal advice, please don't ask them at this time. We're going to hold we can always hold a closed executive session at the end of this briefing upon request. Briefing us today, we have Andrew Trotta, Director of Electrical Engineering. We have Jay Katawala in the Division of Electrical Engineering and Fire Services, and Mary House in the Office of General Counsel. I'm now going to turn the microphone over to our staff to brief us. Thank you.
Good morning, Mr. Chair, Commissioners. I'm Jay Katawala. I'm here with Mary House, an attorney in the Office of the General Counsel that advised on this proposed rule. As you stated, we're here to brief the Commission on staff's recommended draft notice of proposed rulemaking to establish a safety standard for lithium-ion batteries used in micromobility products and electrical systems of micromobility products containing such batteries. Next slide, please. The agenda for this presentation includes the following topics. First, Mary is going to provide an overview of the statutory framework for this rule under Sections 7 and 9 of the Consumer Product Safety Act, or CPSA. Then I will explain the types of micromobility products and electrical components that are within the scope of the proposed rule. Next, we will discuss the hazards associated with these products and the incident data. UL standards and engagement is 3 voluntary standards applicable to these consumer products. So we'll introduce the UL standards that staff recommends incorporating by reference into this rule with specific modifications. We'll also explain the compliance actions CPSC has taken to address the risk of injury. And I will review staff's recommended requirements for the proposed rule. Econ prepared a preliminary regulatory analysis, so I will explain what they concluded. Econ also prepared as required an initial regulatory flexibility analysis, which I will explain. And lastly, we'll review staff's conclusions and recommendations for the draft proposed rule. Now, Mary is going to review the statutory framework for the draft proposed rule.
Next slide. Good morning. The draft proposed rule relies on the Commission's authority under Sections 7 and 9 of the CPSA and would create a mandatory consumer product safety rule for lithium-ion batteries used in micromobility products. If finalized, products that are subject to this rule must be tested and certified as compliant. Section 7 of the CPSA authorizes the Commission to issue consumer product safety standards that consist of performance requirements and requirements for warnings or instructions. These requirements must be reasonably necessary to prevent or reduce an unreasonable risk of injury associated with the product. Next slide. Section 9 of the CPSA contains the procedural requirements for consumer product safety rules under Section 7 and allows CPSC to initiate rulemaking through a notice of proposed rulemaking or an NPR. An NPR must contain the proposed regulatory text, describe any regulatory alternatives the Commission considered, include a preliminary regulatory analysis, contain preliminary findings, and provide an opportunity for both oral and written comments. Next slide. Under Section 9, the required preliminary regulatory analysis must contain a preliminary description of the potential benefits and potential costs of the proposed rule, including any benefits or costs that cannot be quantified in monetary terms, and an identification of those likely to receive the benefits and bear the costs. It should also include a discussion of the applicable voluntary standards and a description of any reasonable alternatives to the proposed rule, together with a summary description of their potential costs and benefits and a brief explanation of why such alternatives should not be published as a proposed rule. Next slide. Section 9 also requires that the Commission make several preliminary findings to issue the proposed rule, which are listed on this slide. And there are 8 of 9 listed here, and I'll let you read those. Next slide. The 9th is regarding the voluntary standards. So Section 9 of the CPSA requires that when a voluntary standard has been adopted and implemented, as the case here, to issue a mandatory rule, the Commission must find that either the voluntary standard is not likely to eliminate or adequately reduce the risk of injury, or it is unlikely that products substantially comply with the voluntary standard. Next slide. Now Jay is going to describe the products within the scope of the rule.
Thank you, Mary. Within micromobility consumer products, there are 2 main groups, e-bikes and other micromobility consumer products, or OMPs. In the first group on the upper left is an electric self-balancing scooter, or ESB scooter. On the lower left is an electric skateboard. In the center is a stand-up e-scooter. On the upper right is an electric unicycle. And on the lower right is a hybrid micromobility product which has features of an electric skateboard and electric unicycle. In the second group are e-bikes. Next slide. This slide shows electrical components within the scope of this proposed rule for electrical systems. On the left is a user replaceable battery pack. The top plastic cover has been removed to show the lithium-ion cells inside, which appear like tubes sitting next to each other inside the battery pack. In the center is an aftermarket charger with various electrical ratings and markings. Finally, on the right is a conversion kit for turning a mechanical pedal bicycle into an electric bicycle. The parts that make up the electrical system are identified around the bicycle picture. The components are the console, charger, throttle, controller, motor, pedals, battery, and pedal assist device. The e-bike conversion kit can be considered a complete electrical system and therefore within the scope of this proposed rule. Next slide. On this slide, we list the other components of the electrical system for micromobility products. First, within a battery pack, we have a lithium-ion cell shown on the upper left. This image on the upper left shows a single 18650 lithium-ion cell. 18650 is a numeric reference to the size of this particular cell. There are many other cell sizes, but this size is a common size for micromobility products. In a typical micromobility product, there may be anywhere from 10 to 40 of these lithium-ion cells within one battery pack. And some larger products may have more than one battery pack. Next is the Battery Management System Circuit, or BMS. This circuit is responsible for keeping track of the electrical and thermal conditions of the battery pack, particularly while charging and during use of the product. On the circuit board image just shown below the cell, you will see two wires coming off of the circuit board. For one of the pairs of wires, you will see a small rectangular shaped object connected to the wires. In this design, that rectangular object is a thermal protector. This protector operates like a switch. When the temperature limit of the battery pack is reached during use or charging, in this example, the thermal protector opens inside, breaking the electrical connection temporarily. When the temperature returns to the operational range, the circuit closes again. When the circuit closes, the consumer can resume charging or usage operation. The second wire on the circuit board could be used to measure battery pack voltage or current to break the circuit to prevent a hazardous condition on the battery pack. The third item is the battery pack enclosure, which is a critical part of the electrical system for these products as it keeps out contaminants from entering the battery pack, which could impact safety. The fourth item is the motor and motor controller. The motor controller properly distributes electrical energy from the battery pack to the motor to use the micromobility product while the battery is discharged. The fifth item is the charger, which charges the battery pack. Finally, there are interconnecting wires which properly transfer electrical energy throughout the electrical system, which are not all shown pictorially on the right side image. Next slide. So this slide is showing testing work that was sponsored by CPSC several years ago. The tests were performed by the Naval Surface Warfare Center, Carter Rock Division. In these photos, an SB scooter battery pack was wired to induce a thermal runaway using a heater cartridge to artificially heat one cell of a multi-cell pack. So lithium-ion cells provide high energy density that is ideal for micromobility products, and cells operating outside of their safe operating region may result in a self-heating, self-sustaining chemical reaction using the flammable cell electrolyte called thermal runaway. The picture on the left shows the battery pack of 20 18650 cells wired for tests. The center photo is the same pack as the left photo, except the metal cover is screwed back on after the testing wires were applied. The photo on the right is showing an explosion of the battery pack when one cell entered thermal runaway and caused enough heat and pressure inside the battery pack to explode violently. Next slide. This is a video of a single 18650 lithium-ion cell that is forced to fail using a nail to penetrate the metal sidewall of the cell, causing a short circuit of the cell. This test was performed by UL Research Institutes. What you will see shortly in this video is the violent rupture, explosion, and ejection of hot gases, which could ignite nearby combustibles if the cell is allowed to fail unmitigated. This is what thermal runaway looks like. Please play
Has
the video.
reached thermal runaway. Thermal runaway can result in extremely high temperatures.
Next slide.
Has reached thermal runaway.
This slide shows 3 different types of micromobility products where thermal runaway occurred on one or more cells of the battery pack. The image on the lower left shows generally how much damage could occur from a micromobility product. Next slide. This slide summarizes the incident data for products within the scope of the rule reported to CPSC between January 1st, 2019 through December 31st, 2023. Staff identified 227 incidents involving 357 victims. Staff identified 39 fatalities, 181 injuries, and 137 non-injury incidents. Of the 39 fatal victims, 8 were 14 years old or less, and 9 were 65 years old or more. Staff identified that 8 out of the 227 incidents involved multiple deaths, and 31 out of these 227 incidents resulted in multiple injuries from a single incident. The chart shows the distribution of deaths and injuries across product categories, showing that e-bikes and e-scooters have the highest number of deaths and injuries. Next slide. So this slide is going over the usage patterns of known incidents. And so these 8 usage patterns, I'll just read briefly. The first is while charging, 108 incidents total. The second is while the product is stored or at rest. The third is during or shortly after riding. The fourth is after an aftermarket battery or aftermarket chargers being used. The fifth is after charging or unplugging the charger from the micromobility product. 6 is the user removing or replacing the battery from the micromobility product. 7 is while the micromobility product is in contact with water. And the 8th is while a consumer assembled or consumer modified battery pack was being used. Next slide. So compliance actions from January 1st, 2016 through November 30th, 2024, CPSC conducted 29 micromobility consumer product recalls and issued 9 unilateral press releases. And that resulted in more than 870,000 units that were recalled, including ESB scooters, e-scooters, e-skateboards, e-unicycles, including hybrid devices, or hybrid products, I should say, and e-bikes. Recalled products were associated with 2 deaths and 31 fire-related injuries. In 2018 and 2022, CPSC issued letters to retailers, importers, and distributors strongly recommending third-party certification of compliance to UL 2272 in the 2018 letter regarding ESB scooters, and that was then followed up with another letter in December of 2022 covering micromobility products generally, which covered for the standards UL 2272 and UL 2849. Next slide. So the applicable voluntary standards for these micromobility products are as follows. The first is UL 2849, which covers electrical systems for e-bikes. That's the first edition that applies to e-bike micromobility products. The second is UL 2272. That is the electrical systems for personal e-mobility products. That's the second edition, which applies to OMPs in the draft notice. The third standard is UL 2271, which covers batteries for use in light electric vehicle applications, and that standard is applicable to user replaceable battery packs. Next slide. So for assessment of the UL voluntary standards, UL 2849, UL 2272, and UL 2271 address many, but not all of the identified electrical, fire, and shock hazards. The voluntary standards do not adequately address a scenario of a user riding until the battery dies and immediately plugging in to recharge the battery at a higher maximum charging temperature. The standards do not adequately address risks associated with users accessing the battery compartment to make repairs or modifications. The standards do not adequately address damage to the battery due to an incompatible charger. So in this example, it could be applicable to a reverse polarity charging. Voluntary standards also do not adequately address warnings for batteries that the consumer may have assembled on their own, charging frequency, cooling down the micromobility product after each use and before charging, instructions on submersion, user replaceable battery packs to indicate that a specific micromobility product, brand, or model that it's intended for. The UL standards do not include requirements for aftermarket chargers, replacement batteries that are sold separately, and also e-bike conversion kits. Next slide. So relevant to these micromobility products are also European voluntary standards. The first is EN 15194, which covers electrical power assisted cycles. Those are applicable only to bicycles where you have a pedal assist feature. The second is EN 17128, which essentially covers the other micromobility products. It has a long title. You can read it on the screen there. And those for the EN 17128 standard, for those products, they're applicable to micromobility products with speeds less than 25 kilometers per hour or roughly 15 miles per hour. Next slide. So in the assessment of the EN voluntary standards, EN 15194 is limited in scope to pedal-assisted e-bikes. That standard does not include requirements for electric shock and fire, and the requirements are generally inadequate for the incidents that we are trying to address. EN 17128 is primarily focused on mechanical performance of micromobility products, and so that standard does not include comprehensive requirements for electrical systems. Next slide, please. So compliance with the UL voluntary standards, CPSC conducted a 2023 survey of brick and mortar retail stores reviewing micromobility products for the presence of the UL mark. The survey found, when weighted by sales, a compliance rate of approximately 45% across all products and below 11% for e-bikes specifically. Together with the substantial number of deadly and injurious incidents, UL standards have not reached the level where risk to consumers is adequately mitigated. Next slide. So on this slide, we relate the hazard and the usage pattern to the incidents, the UL requirements at present, and then finally additional requirements that staff is proposing. So for the first usage pattern while charging, there's 108 incidents. There's a BMS requirement presently within the UL standards, as well as charging tests required in the UL standards. Staff proposes that additional requirements that the charging tests be done immediately after discharge, as well as a reverse polarity charging test. For the second usage pattern, while the product is stored or at rest, there's 22 incidents. The UL requirement at present requires BMS and certified cell requirements. However, for this usage pattern, because the battery is not necessarily being stressed for this particular usage pattern, staff has not proposed any additional requirements for this usage pattern. The third is while during or shortly after riding, 14 incidents. The UL standards currently require BMS and discharge tests, and staff is additionally proposing testing for charging immediately after discharge. For the fourth, using an aftermarket battery or charger, there's 14 incidents. There's no UL standard to address this specific usage pattern. However, staff is proposing that the battery require UL 2271 tamper-resistant enclosures, as well as warnings and instructions. And for chargers, require UL 2849 or UL 2272, depending on the micromobility product that the charger is intended for, as well as reverse polarity charging test and also additional product information. For the fifth usage pattern, after charging or unplugging the charger, there's 11 incidents. The current UL standard requires a BMS and charging tests. However, for this type of usage pattern, when the charger is unplugged, again, the battery is not being stressed, and so staff does not have any additional proposals for this usage pattern. For the user removing or replacing the battery, there's 8 incidents. There's no UL requirements at present. Staff is proposing tamper-resistant enclosures and additional warnings. For using consumer assembled or modified battery packs, there's 4 incidents. There's no current UL requirements. Again, staff is proposing tamper-resistant enclosures and warnings. And finally, for micromobility products in contact with water, there's 3 incidents. The UL standard currently has ingress protection requirements, and so the proposed additional requirements for this usage pattern are instructions on submersion. Next slide. So the proposed requirements, staff is recommending incorporating by reference electrical requirements for e-bikes to comply with UL 2849 and other micromobility products to comply with UL 2272. Additionally, adding revised requirements for tamper-resistant battery enclosure to UL 2849 and UL 2271, adding the post-discharge charging test to UL 2849 and UL 2271, adding a reverse polarity test to UL 2271, 2272, and UL 2849. Finally, adding revised marking and labeling requirements to UL 2271, UL 2272, UL 2849. Additional products within the scope are user replaceable battery packs that are not sold with a micromobility product, that those battery packs comply with UL 2271. Aftermarket chargers comply with UL 2272 if intended for a personal e-mobility product, and with UL 2849 if intended for an e-bike. Finally, components marketed for and sold as part of an e-bike conversion kit comply with UL 2849. Next slide. So Section 9 of the CPSA requires preliminary regulatory analysis. So the estimated annual costs are $154.96 million. The range of annualized estimated benefits are $100.1 million, conservatively underestimating benefits with likely uncounted incidents. The upper bound estimate is $579.7 million if e-bike fatality rate aligns with e-scooters. The estimated annualized net benefit range is from negative $54.85 million to positive $424.7 million. And so the resulting benefit to cost ratio is in the range of 0.65 to 3.74. And these are estimates in 2023 dollars, discounted at 2%. Next slide. So continuing with the preliminary regulatory analysis, these are the alternatives to a proposed rule. We can limit the scope of the proposed rule to other micromobility products, batteries, chargers, and e-bike conversion kits. We can continue to improve information and education campaign. We can conduct recalls. We can work to improve the voluntary standard for micromobility products. We can delay the effective date. or we can take no action at all. So while these alternatives would have minimal costs compared to the proposed rule, the alternatives are unlikely to reduce the associated risks of death and injury to the level that the proposed rule purports to accomplish. For this reason, staff recommends to the Commission our proposed rule. Next slide. So continuing with Section 9 regulatory flexibility analysis, it's estimated there are 36 small manufacturers and 20 small importers that sell micromobility consumer products, and it's estimated that 10% of these are domestic. Small businesses are expected to incur procurement costs. The cost to modify will be dependent on component costs and what existing testing and compliance programs they have in place to test the resulting electrical system. CPSC staff expects the cost of the draft proposed rule to be larger than 1% of gross revenue for most firms, and therefore the rule is categorized as having a significant economic impact. Next slide. So staff's assessment and recommendations, the requirements in UL 2849, UL 2272, and UL 2271 are inadequate to eliminate or adequately reduce the unreasonable risks of injury because they do not address all identified hazards. Staff estimates compliance with the draft proposed rule would mitigate about 90% of deaths and injuries in addressable incidents. Staff recommends adding performance marking and labeling requirements to adequately reduce the associated hazards. Next slide. So continuing with staff assessment and recommendations, the weighted compliance rate for the UL standards across all product types in use is about 45%. Compliance has not yet reached the level where the risk from these products is sufficiently mitigated and consumers can expect a reasonable level of safety. Staff recommends including an anti-stockpiling provision, which is intended to prohibit manufacturers and importers from stockpiling non-complying products after publication of the final rule, but before the effective date. So staff recommends an effective date of 180 days after the final rule is published in the Federal Register, which is the longest effective date permitted under the CPSA, unless the Commission finds for good cause that they determine that a longer date is necessary. Next slide. So this slide identifies the NPR team. I wanted to thank them for their contributions to this effort. And with that, I'm happy to answer any questions.
Thank you very much. It was a very comprehensive briefing on a complex topic. So I appreciate both you and the team's efforts to get us to this point. At this point in time, we're going to turn to questions from the Commission. I'm going to start with myself. As you noted in your presentation staff package, that there are European standards for electrical systems for micromobility devices, and some people have suggested that is a good area for the Commission to take a look at. But haven't chosen that standard as an option, and in the presentation you noted that it doesn't include address certain things and that inadequate in some ways. Can you expand upon that? What are you finding as inadequate? What are the issues that are not being addressed by those standards?
Sure. Really, when we're talking about analyzing the electrical system, we're talking about two main ways that the product is used. It's either being charged or it's being discharged while the product is used out on the however the consumer uses it. And so for those two basic uses of the product, the UL standards address those one of those two ways more directly. And so with the European standards, they could be viewed as being a little bit more broad in terms of the requirements, covering many topics, but not really focused on the types of incidents that we would try to mitigate. And so for that's where the UL standard is doing a better job at more directly addressing those two types of uses.
I would also add to what Jay said that the European standard for bikes only covers the electrically pedal assisted type variety, and the UL standard covers both that and fully powered bikes. We'd also indicate that in Table 9 of the briefing package, there's a detailed analysis that Jay conducted for comparing the UL bike standard to the UL standard.
Thank you. Appreciate that one. I'll take a look at that more carefully. Staff also provided a range of cost estimates when it comes to the cost benefits of this rule, and a conservative estimate and an upper bound estimate. Can you explain the approach that you took and what are the key variables in determining where in the range that we may end up?
Sure. So I'd like to invite Alex Moscoso, who can answer that question for you.
Good morning, Mr. Chair. Thank you for the question. We provided two estimates to provide proper context for the rule to give a range of plausible net benefits. This rule offers requirements for fairly new products that have only been around for a decade or so. This leads to a lot of uncertainty in the data and the incident data and in data collection. When there's collecting the data, there's not always a product category that increases the likelihood for undercounting the incidents. So in our initial estimate, we felt it should be framed as a conservative estimate. We feel this is the minimum number of incidents. And we wanted to give an additional a range to what the data would look like to account for that undercounting. And what we decided to do was to tie the fatality rates for e-bikes, which is the youngest of the product categories, has the lowest death rate on the observed data, which again, we think is undercounting, and tying it to e-scooters, which is the most mature market out there, has the highest death rate. When that happens, then you have the upper bound estimate and in a range of plausible net benefits that we feel that should fall between somewhere, hoping to use the notice and comment period to collect more data.
Thank you. Yes, certainly it was over the years I've been hearing more and more about the fires and the devastation that they've been causing. I welcome people to comment on that, but the trends certainly seem to have been going up as opposed to going down. At this point in time, I'm going to turn to my colleagues for their questions, but thank you again for the presentation. Commissioner Feldman.
Thank you, Mr. Chairman. And first to Mr. Cadwalla, Ms. House, and Mr. Trotta, Mr. Moscoso, thanks for the presentation today, as well as everybody else that's listed here that worked on this briefing package. I just want to thank everybody for the hard work on what is a critical issue. We're well aware of the risks to safety and property posed by lithium-ion batteries and e-bikes and other micromobility products. So for that reason, I'm pleased that we're here today and are now in a position to consider safety standards for the prevention and reduction of the unreasonable risks associated with these products. I want to start to ask specifically about the additional and revised requirements the staff's proposing on top of the existing UL standards. And there are three main standards that we're looking at that we discussed today. Have members of the various UL committees shown any willingness to expand the scope of the existing voluntary standards to cover the additional requirements that staff's proposing? For example, has there been an openness to require tamper-resistant enclosures, or is there some technical or other reason that UL has thus far declined to include those requirements?
Thank you, Commissioner Feldman, for your question. I guess the best way that I could answer that question is there isn't any reluctancy necessarily to address anything. I think it's healthy discussion within the technical committee. So I don't see a reason to believe that the committee would not be open to considering any of the items that would be proposed.
That's good to know.
I would add that we had that the UL Technical Committee had made some changes to UL 2272 that was published in 2024 based on some recommendations that staff had made to follow up on what Jay said.
Thank you. And presumably the comment period would be an opportunity to solicit additional feedback and data points from the UL Technical Committee about support, opposition, or any technical issues that might arise. So
I would just add, whenever we're looking at voluntary standards, timing, right? They're on their own time. They're not necessarily on CPSC time. So that's also something to consider.
fair enough. Thank you. Where staff is proposing some scoping changes to include additional products like the user replaceable battery packs or aftermarket chargers, I'd like to learn a little bit more about the market for these products that currently exist outside of the scope of the voluntary standards. These are primarily non-OEM aftermarket components. Is that fair?
It can include an OEM battery as well. So the example that I will give is maybe the model number is slightly different from what the exact model number is of the supplied battery, and it may have identical or very similar characteristics. But in how the proposed rule has been drafted, that would be considered a replaceable battery rather than the OEM battery.
Okay.
So that may include other batteries that are manufactured by other manufacturers, and so we want to make sure that those batteries are considered because they would pose the same risk to the consumer as other batteries.
Okay, thank you. And you say in the briefing package that most of these e-bikes and e-scooters and the OMPs on the market are manufactured and imported from China. Do you have information about where these replaceable battery packs and aftermarkets are manufactured? Is it primarily the same?
That's our understanding. It's mostly produced in China.
Okay. And are these generally associated with known brand names, or should we think of these product categories as including non-branded and difficult to trace components?
I would say that they're fairly difficult to trace. The reason being is when you have a battery pack, unless you actually open it up, it's really hard to gauge what components are inside of it. And so as I described in the presentation, this is an electrical system. And so all of the different pieces that go into that electrical system are critical at protecting the whole system and the product and ultimately the consumer.
Very good. Thank you. Last question. Taking a bit of a step back, we're discussing today in NPR on lithium-ion powered micromobility devices, and I'm curious to hear staff's thought on whether or not it might make sense to pursue requirements that are chemistry neutral. For example, high density batteries generally, which would include lithium-ion battery systems. Would that ensure protections across the board if new battery technologies were to replace lithium ion? Do we have enough data on high density battery technologies other than lithium ion about whether they share the same or similar risk profile? And I'm not advocating necessarily a particular policy direction, but I wanted to hear staff's thoughts to make sure that this NPR is reasonable in scope.
Sure. Your point understood, Mr. Commissioner. So to that effect, really, the UL standards really are not going to prescribe any designs or design restrictions. Ultimately, it will come down to a performance test to ensure what that level of safety will be. So generally speaking, those standards are open-ended when it comes to the design, but really when that design is subjected to that performance test is where we find out whether that product does meet that adequate level of safety or not.
That's helpful.
I would add that we have a major program for high energy density batteries. So we looked at a lot of different technologies. We're looking at the state of the art right now for the micromobility device products. So that's really what we pursued, and we'd be flexible to maintain, to be assured of what those changes are made, if different chemistries came into use.
I appreciate that response. Excellent presentation. Thank you all very much.
Commissioner Trumka.
Morning. Thank you all for your work in getting us here today. Thank you for putting a lithium-ion battery package before us. It feels like we've been talking about this issue for too long, and it is time to move forward. So thank you for getting us here and the thoughtful package you put before us. I'd also like to thank you for addressing, one of the issues that I'm concerned about with these, and that's tamper resistance with the standards you put in here. People opening up batteries and swapping cells is one of the biggest problems that I hear about leading to these battery fires, particularly in New York. And to prevent that, the rule has two requirements. One, that the battery case has ultrasonically welded or secured or is secured by other equivalent means. And two, that the battery pack can't be opened with common household tools. And I think those are good solutions for making it harder to open these and making it obvious to people if they have been tampered with so that they can avoid them. So that is a solid approach. Given the technical strengths of the rule, I was a bit surprised at first, on first reading, to see that the estimates of deaths and injuries are as low as they are. And you've explained why today and in the package, why we've undercounted those a bit, why we think we're undercounting those. And there's a variety of reasons for that. But, let's say we're just undercounting deaths by 5 deaths per year. What would that do? How would that affect a cost benefit analysis? And is that within the realm of possibility?
Thank you for your question, Commissioner. Just taking the conservative estimate that's based on data, there's an annualized negative net benefits of around 50 million. So if there were, on average, a little more than 4 deaths were missing each year of our observed data, then that would make up the difference. And so just as a break-even analysis, about 4 deaths a year.
So if we were underestimating by just a little over 4 deaths per year, that would be a break even on the cost benefit. And is that within the realm of possibility that you're contemplating?
We would like to see the data, but certainly given the nature of these devices, that could go off in a multi-dwelling unit, there is the potential for a missing incident that has a large number of deaths.
Okay. And I'm glad you mentioned that, because you also mentioned in the package that in New York alone, over 400 buildings were damaged in lithium-ion battery fires. And we can't include those incidents in this NPR data analysis because there may be some gaps in that data where it's not exactly clear which types of products were involved. And so, one question there is, should we see comment from people or groups like FDNY who might have more detailed information on those incidents?
I think we do welcome those comments.
Okay. I really hope we hear from them, and I want to make sure we capture the full picture of the harm caused by this product category. So I hope we get outreach, not just from FDNY, but from fire departments across the country. And I hope they come forward with death and injury data from these fires, and hopefully we can incorporate that and make sure we get a full picture. We've also noted the difficulty in getting information on property damage. And, we've got a pretty small dollar figure identified of what we know and is traceable right now in this package. And that's one area where I really hope commenters come forward with better information to fill out that full range of property damage. Because as you pointed out, if a whole apartment building is damaged in one of these incidents, that could be in the many millions of dollars in just one incident. And if we're missing one of those, there was a CBS News article in November of 2022 that talked about a single lithium-ion battery fire in Manhattan in a high-rise where firefighters had to rescue people on the 20th floor. 40 people were injured, some critically, and 11 firefighters were injured. When we need to get that data into there, we need to figure out what the property damage total is, because I think that really could drive the numbers on this. And I also think we should talk about some of the unquantified benefits, and hopefully we can see comment on that when we're talking about things like, you don't know if your neighbor's apartment, an e-bike in your neighbor's apartment that you've never seen before might cause your apartment to catch on fire. Giving people some peace of mind from those type of fears, as much as this is publicized, I feel like we should quantify that as much as we possibly can, or at least point out that unquantified benefit if we can't. And likewise, we have multiple, I think there were 39 incidents where there were multiple deaths from lithium-ion battery fires, from micromobility products. And if any of those people are in the same family, I think we've talked about this before. 2 deaths are tragic, but losing 2 members of the same family feels like there should be a multiplier on that. And so I'd invite us to think through that, and I hope we get some comments to address that. But going back to the technical side, another big problem that the NPR does a good job of addressing is incompatible chargers. And you do that through a number of means, including through addressing the reverse polarity. But there's also the requirement for aftermarket chargers to be marketed with a marking that says use only with, and then the name of the manufacturer and the model of the product. And question there is, where do they have to mark that? Is that a requirement for on the physical product itself or anywhere else?
I think it's on the physical product itself, but let me take a look and get back to you on that because I think we've talked about this before. We have this requirement in other standards, and I just want to make sure we're having the same requirement so that it's marketed, intended, or designed.
I think that'd be great because you've anticipated what I'm getting at, and the question is, I imagine if you're buying a product online, you're going to check compatibility when you make the purchase. And so if you're looking at the online listing, it's going to say this is compatible with X, Y, and Z. You may rely on that. And so when it comes in the mail, you're not going to check the product again to make sure it was really compatible and look at that marking. So if it's required in both places, that would be a benefit. And I guess as you look at that question, the one that comes up is, would anything in the NPR as drafted prevent manufacturer from complying with that requirement if it's only on the physical product? So this is only to be used with make model, but then having an online listing that says this is a universal charger or it's compatible with a list of 1,000 things, would that be prevented?
Would that be?
I was just looking at the reg text. It does say marketed, intended, or designed. So
would that be prevented?
I think so. Yeah.
Okay. And I guess a more specific question, that's good to hear. A more specific question is, we've warned about universal chargers in general, and we don't think there are universal chargers. And so when there's an incompatibility issue, it creates a hazard. Would anything prevent the use of the term universal charger specifically in marketing?
Well, it wouldn't be factually, if it's factually correct, no, but if it's not factually correct, then it would be not in compliance with this requirement.
So I guess the question is, could it be factually correct for anything? Are there any real universal chargers?
So that really depends on what the mating connection, the type of connector that's used. In my observations with these products, I have seen mating connections that appear to be used for products other than micromobility products. And so that is a legitimate concern. And so that's where these performance requirements will ensure whether that connection is actually keeping the consumer safe.
Okay.
I would just add that universal is a vague term. I don't know how we could necessarily prevent that. And there could be equivalently rated chargers that are actually compatible with the device, with the products.
And also that are incompatible. I mean, if we don't think...
Absolutely, both ways. But they could also be, to your question about universality, there could be, the same, an aftermarket charger could be rated equivalently.
Right. And I think if we have all the issues with reverse polarity and with, with current and all the things that you're protecting against, if we're worried that universal chargers don't actually exist and that they could pose a hazard, we may want to get explicit and say, don't use those words. And maybe that's something we learn about through the comment period and can study there. In that same vein, we're also cutting a requirement where we're giving the advice, the warning to only use the charger that came from the manufacturer of your product. And are we losing something by, should we be getting rid of that, or does that advice still have value?
So in terms of testing the entire electrical system, it's tested with that specific charger as a system. And so when that system is qualified, you could really only apply that all of the results of those performance tests for that one electrical system, which would be specific to that charger, qualifying that together with the battery pack and the other components as one electrical system. So the best way to address anything other than that specific charger would be to make sure that any alternate charger is tested properly with the other electrical system components together.
Do we have any requirements in this rule for the chargers to be tested like that?
So within the micromobility product standards, they do have component standards for testing the charger in order to qualify it to be used in an electrical system. And in addition, in the micromobility product performance requirements, that same charger would then be qualified with the battery pack and the other components of the electrical system for the entire micromobility product.
Can I add something?
Briefly.
Okay. There are requirements within the proposed rule for aftermarket chargers.
Thank you. Commissioner Boyle.
Thank you, Mr. Chair, and thank you to everyone on the panel for this work. This has been one of my top priorities. I've been out to the lab multiple times to meet with you all, so I know how much work went into this, and I really appreciate that we're at this point. So thank you very much. I do have a couple of questions, though. I think this is for Ms. House. On page 6 of the draft NPR, it states that the commission preliminarily determines that the voluntary standards are inadequate to address the risk, and that overall the micromobility products do not substantially comply. So just to be clear, if we determine the standards to be adequate, say UL adopts some of these changes in the voluntary context, we still are capable of proceeding with rulemaking because we've determined preliminarily there is not substantial compliance.
That's correct.
Okay, thank you. And in terms of the various voluntary standards that the draft proposes to adopt, UL 2849 addresses e-bikes and 2272 for the personal e-mobility devices. And Mr. Cadwalla, could you explain why there are different standards? Is there something unique about e-bike systems?
So really, there really is not very much difference at all for the electrical systems. Really, this is more of timing. So in 2015 and 2016, when the ESB scooters came to market, the technical committee moved very quickly to create a standard for those products, which was published at the end of 2016. But they realized after that we may have left out e-bikes. Okay. And so the e-bike standard was published in 2020 with very similar requirements, but the design for bikes is different. And so I believe it was slide number 8, we had separated the e-bikes from the other types of products because the physical design is different from the others.
Okay, but initially it was because of timing and the lack of maturity in the e-bike market. Is that?
Well, I'd also add that bikes are slightly different. We have electrically power assisted where the user would be pedaling and the motor be assisting. So that's a unique requirement from some of the other products.
I see. Okay. And just sort of following on that, on 2272, it incorporates a category of hybrid micromobility products. In your view, is that category broad enough to cover, new products that might emerge in the market so that we're not in that same position of kind of falling behind in a timeline?
I would say generally speaking, yes, but even I'm surprised at some of the physical designs that I see as this the market of these products evolves. But in terms of the electrical system, it would most likely be evaluated very similarly to what it is currently. Now, whether that warrants a new standard or not is still to be determined.
I would add, I'm sorry, I would add the UL 2272 has a slightly broader scope than what we defined, so that could be accommodating other products.
I see. Okay, thanks. I know we've mentioned New York City here. I'm a native New Yorker, so I have a special interest in it, and we've had the fire commissioner here, and now I understand, and again, maybe partly this is Ms. House, but just to confirm that my understanding is that the law in New York now requires bikes or micromobility products to be in compliance with these UL standards. Is that correct?
That's my understanding, that New York City has a local law requiring that.
Okay. Now, do we have data? Have we been able to evaluate? Have we been in touch with New York to evaluate the efficacy of that law and whether the fires have, there's been an impact? Mr. Boniface?
Yes, thank you. We continue to work with FDNY and others to make sure that we have the data that they have as well. I think that anecdotally, they've noted there has been a reduction. However, we've not seen sort of a substantive analysis that we felt we could rely on that captures that reduction.
Okay. Are we aware of other jurisdictions who have adopted similar legislation?
I believe California has recently passed similar, I think it's state law and is signed by the governor requiring micromobility's products to adopt the UL standards.
Okay. And again, have we been in touch? Have we been coordinating with them?
This was passed fairly recently and well into the rulemaking process. So we were made aware again late in the rulemaking process, and I'd have to look back at the effective date of when it goes in place, but it is recent, so I'm not sure its impact would have been captured right now. But we hope to have comments taken in during the NPR.
And Ms. House, if I understand correctly, in New York City, the local law adopted just straight up the standards. There were no
That's
changes.
correct.
Okay, thank you. Again, Ms. House, I think this might be for you. On page 9 of the draft NPR, where it talks about jurisdiction, the draft states that the CPSC has jurisdiction over products such as racing bikes, ATVs, and scooters, but not motor vehicles intended for on-road use, which it states generally have on-road capabilities such as headlights, taillights, brake lights, and side mirrors. I just want to clarify, that doesn't mean that a product that has those features is not a consumer product, correct?
That's correct. It's more holistic and considers whether the product requires a VIN, which is what NHTSA requires. So we talk to NHTSA about products. So
I just wanted to confirm that.
Okay.
Thank you. And Mr. Cadwal, I want to ask you about the battery management systems to make sure I understand that. As I understand it, it plays a critical role in the safe operation in terms of stopping thermal runaway. Is that broadly correct?
It's kind of difficult to answer that question. The BMS is not necessarily a device that prevents thermal runaway, but it will address the conditions that contribute to thermal runaway and try to minimize those. But there are also circumstances of, say, manufacturing defects within cells and other conditions that also play a role in the likelihood of a cell going into thermal runaway that are not necessarily related to that BMS performance.
Anticipated my follow-up question was what happens with the defect and does that address it? And you're telling me no,
That's correct.
contaminant or something like that.
So the idea is that the performance test would potentially catch that type of defect, but the performance test in the standard may not be able to catch all of those defects.
Okay, thank you. Mr. Trotta, I want to give you a chance. You were trying to jump in.
Thanks. Thank you. I appreciate that. I would just say that the BMS is intended for that purpose to prevent the electrical conditions that could result in thermal runaway, for operating conditions that you would expect.
Okay.
And as Jay mentioned, the defects aren't identifiable, but there's both standards require that cells are produced with are certified cells. So that hopefully minimizes the likelihood of a defect, but not, of course, doesn't prevent it.
I just have a couple of questions on the data. I think you've identified 227 incidents, if I recall correctly, and I just want to break them down a little bit. That 122 occurred while the product was plugged in and charging, and 24 were reported while the product was being stored or resting in place. So it's a total of about 146, and if my math is right, about 65% of the incidents. And then 22 incidents involved a user removing or replacing a battery pack, and 4 involved homemade batteries, so about 26 incidents. So I just want to ask you if it's fair to say that only a small fraction of the incidents that we're looking at and seeing can be attributed to what is frequently referred to as consumer misuse.
Again, I want to qualify the answer with these are known incidents. Of course, there is that undercounting that is at play here. If you could just repeat the question one more time.
Well, I would just looking at the type of incidents, and it seems to me that the vast majority are involve the product itself, not involving a consumer action that frequently we hear about something a consumer did. And if it's either so I'm just trying to see if we can characterize the data that way.
Yeah, I think if you look at the incident analysis, it clearly shows that these things were plugged in after use and caught fire, or this caught fire after being brought into the home or so forth after use. Clearly not misuse type situations.
Do we have a working scenario of why a product that is not even plugged in and is just sitting stored will explode?
So there is some natural fade of the battery pack when it's stored. So after the product is used or charged, if it's sitting for a long time, even though the BMS is using some of the electrical energy from the battery pack to detect those conditions, it is possible that that cell will it will get discharged on its own just from not having been charged often and used regularly. And so that's one of the conditions that it's really difficult for the BMS to protect against, because that's actually the chemistry at play, not necessarily any electrical parameters.
Okay, thank you. I appreciate it. Thank you, Mr. Chair. My time's up.
Commissioner Ziak?
Thank you. And before I get started, I'd like to say a few words congratulating my friend and colleague, Commissioner Feldman, who will start service as the acting chair shortly. Peter and I have known each other a long time. He's been in public service a long time, and I'm sure and confident that he'll continue to do great work on behalf of American consumers. I'd also like to thank our current chairman, Alex Onsarek, not only for his service here at the commission, but his long history of public service. Alex left the commission, at least in terms of his service as chair, better than he found it. So thank you to both of you. Next, I want to thank staff. This is a very complex issue. There was a number of folks, and my colleagues have thanked all of you. I want to do the same as well. I think it's important that we examine the very serious and growing risk of lithium-ion battery fires. As we've heard today, the market for micromobility products continues to expand each year, and so is the number of incidents, particularly from fires from lithium-ion batteries. The number of dangerous incidents is with the number of fatalities is quite astounding. I appreciate that today we are appropriately focused on the safety of lithium-ion batteries and micromobility devices. They pose what seems to be the most widespread and significant risk to date. However, I believe and want to point out that I don't think the risk from lithium-ion battery fires, based on conversations I've had with staff, based on visits to universities, including the Battery Institute at Virginia Tech, is limited to micromobility products. As these batteries become increasingly ubiquitous, we need to be committed to addressing their risks when used in other products throughout the home. For example, last night, as I was working on my words for today, I counted 5 large energy battery-powered lithium-ion battery packs in my home. My colleagues and I, during our priorities hearing, heard from several different witnesses talking about lithium-ion batteries, and I'd asked the question to one of the witnesses whether or not the risks were limited to micromobility, and she stated clearly no. She used an incident where a friend had seen an electric toothbrush caught fire. Equally or more troubling, recently I saw a news report about lithium-ion batteries on U.S. airlines. According to the report, and citing FAA data, lithium-ion battery fires are up 388% on domestic airlines since 2015. According to the same reporting, these incidents were happening on an average of twice per week in American Airlines. Someone who flies regularly, this was an alarming story. So we're moving forward on this particular product segment. I believe additional study is also needed to understand the risks beyond micromobility. Work on these batteries is important, and I encourage stakeholders to comment
on this particular NPR, and I look forward to reviewing those comments. Which leads me to some questions, many of which my colleagues have asked, so I'll skip a few of them. On the greater safety concerns, I'll leave this to the engineers. Am I correct to say that the lithium-ion fire battery risk is not limited to micromobility devices generally? And realizing that we're talking about those specifically today, but I believe it is greater than that. Is that a safe and correct statement to make?
Yeah, and I'll jump in. That is an absolutely correct statement. We see the lithium-ion batteries used in a range of things, as you know, from toothbrush to power tools to these products. We've seen all the way up to whole home recharging stations. Of concern in here is the flammable electrolyte. Obviously, you have a greater energy potential as you get a larger battery pack than, say, your toothbrush or so forth. We have efforts underway to look at safety steps in that full range of products and have extensive voluntary standards work with UL and others on that.
Great, thank you. Some of my colleagues, I believe, have mentioned about other jurisdictions' requirements in terms of micromobility devices and lithium-ion batteries. I look forward, and won't ask the question that I originally had, but I do look forward to comments on the compatibility of our rule with those rules, the differences, the advantages, and some of the disadvantages. So I am looking forward to that in the comments. One additional question and comment, again, related to a question I asked during the priorities hearing of a witness. We have the tamper resistance in the proposed rule. I think there is some inherent tension, or at least I'm concerned and would welcome comment to and welcome comments probably from Ms. House, but also from our engineers in terms of right to repair laws. States have, like California and others, have pushed for right to repair laws. Our sister agency, the Federal Trade Commission, also has not only pushed for right to repair, but also sued entities when they restricted right to repair. And I'd welcome comment on how or if there is any inconsistency between right to repair and our rulemaking, or how we can reconcile those two different concepts.
I'd like to get back to you on the essential question, but I will say we looked at right to repair laws when we were doing the button battery rule and found that adopting the UL standard did not run afoul of those laws. So I think I haven't looked at it specifically with this. So I would get back to you on it. But in the past, when we looked at adopting voluntary standards, that was not the case.
Okay. And again, I'll leave it to the engineers to the extent that they have thoughts, but also I would encourage stakeholders to comment on that issue. Gentlemen, if you had any questions.
Yeah, I think we look forward to comments on that issue. It's a challenging issue. At the end of the day, do you want a consumer to be peeling apart a battery and playing with that? I think we have some real challenges.
Well, and I can't recall if this was the lithium-ion battery forum that we hosted or if it was the priorities hearing, but one of the witnesses was an engineer who I believe said something along the lines that he was an engineer, but not an engineer who felt comfortable working on these types of batteries. Mr. Boniface is nodding his head. And that really struck me as something where, as somebody who likes to try to do things myself, with a father who never put anything out to someone else that he could do, there is that recognition that there are just some things that are technically beyond the technical breadth and depth of most consumers, even highly skilled consumers. So thank you for the work on this. I look forward to the public comments.
Thank you. We've had a request for a second round of questions. So I'm going to start realistically with comments. Commissioner Boyle asked my question to some degree with respect to really the whether or not the UL standard is being adopted by industry out there. I believe, Mr. Cadwalla, you had said that the estimate is about 11% from the analysis market survey that you did with respect to e-bikes. That is a surprisingly low number and disappointing to some degree, given that the commission has been asking and urging manufacturers and retailers to really sell things that meet the standard that's out there, and does note that even if we're looking at just the voluntary standards out there, there doesn't seem to be hitting the marketplace in the way that we would hope to be able to protect consumers. And then right to repair, I look forward to having comments on there. I would just note that it's not just the ability of an individual to go and open batteries, but whether or not there are people who are not affiliated with the manufacturer who have maybe experts in repair that be able to engage in sort of an alternative to be able to provide services to consumers. So it's a broader issue as well. With those comments, I'll turn to my colleagues. Commissioner Feldman, do you have any additional
Thank
questions?
you, Mr. Chairman. I wasn't planning to ask this, but since we're doing a second round, I will. To follow up on the line of questioning that Commissioner Ziak was asking, we're focused today on lithium-ion batteries systems in micromobility products. But is this product category, micromobility products, is that even the leading cause of lithium? Is that the leading culprit when we're looking at lithium-ion battery fires generally, or is it something else?
Yeah, I think we've seen it as the leading category. If my recollection of our EPI reports is correct, I think you have to consider the ubiquity of the products. We're seeing a large number of these products, particularly rapid growth of the e-bike market. That combined with sort of I alluded in the earlier comment to energy potential differences as you go from, let's say, a drill battery pack where there's a lot more of those on the market up to a micromobility product, all the way up to like a home energy storage. You have significant increases in the energy involved. And so that brings about, if you have a fire, if you have a problem, that creates much more significant problems.
Okay. If staff has some more detailed data on a product category using lithium-ion batteries versus incidents, I'd be curious to see that. Thank you. I have no further questions.
Commissioner Trumka?
Thank you. One thing I wanted to highlight was I particularly appreciated the thoughtful request for comment about flame retardants in the battery compartment. And so the UL standard would require, if you're using a plastic battery pack to contain the cells, to have VO-rated plastic, which would practically require the use of flame retardants. You've asked for comment on whether we should do that. I think there's real questions as to whether, is there value to it? Is that going to prevent thermal runaway or an explosion if there's thermal runaway in a cell within the pack? I don't think so. But if there's benefits to that, let's think about them. If there isn't, then should we put potential toxins in a product? So I appreciate the request for comment. I hope to see some interesting feedback on that. I also wanted to highlight one hazard pattern that you talked about a bit that surprises me a little bit, and that's the infrequent charging issue. And I don't know if people know about this as much as they should, based on reading this package. It should be a little bit alarming, and it suggests that if a battery sits uncharged for some period of time, it can create a thermal runaway issue either when it's sitting by itself or when you charge it again. And the package highlights one incident where 2 children were killed in this way with a battery pack that hadn't been charged for 3 months. Now, 3 months does not sound like a long time to me, particularly right now. You could picture a kid getting one of these for Christmas, riding it around that day because they're excited, but then there's snow on the ground. You're not going to charge it again until the spring when you can actually drive it outside. So do we have a number of months or weeks or whatever it is that we say you should charge it every so often? Like, do we know that number?
We don't have a specific number, but we recommend in the package that the manufacturer supply that number. As Jay had noted earlier, self-discharge of the cells, and then getting to below a certain point of safety, and then recharging them could be the issue. The BMS may address that, or it should address that. It's if the cells are too low of a voltage to be charged.
I really hope we don't have to come to the conclusion that we have to rely on manufacturers to set each of their own different timelines for this. I hope we can figure out through the comment period what the appropriate timeline is, because I think we need to give people advice on that and say charge, even if you're not using a charge at every X number of whatever unit of time there is appropriate. And I think we should also ask in the comment period about whether there's a performance standard and what that could look like as to whether these products should be able to sit for certain periods of time without being charged, without creating an issue. One of the major issues that we've talked about for driving deaths from these products is chop shops in cities like New York that are swapping battery cells and creating issues that way. And the package adds a warning not to use homemade battery packs. I think we mean to intend those chop shop batteries too. We're really talking about any modified aftermarket battery. And so should we ask for comment on whether that's the appropriate word so we make sure we're capturing in consumers' minds the entire category we're talking about?
We would welcome comments on everything in the proposed rule, including verbiage for the warnings.
Okay, so including that. The NPR also seeks comment on another issue that I've raised, and that's, some fireproof labeling on these things, because we know that when a thermal event happens, it could destroy this. We might not know, the consumer might not remember the exact product that they had. And so should we see comments on a fireproof marking to solve that problem, materials, dimensions, where to place it? I think that's something we should look into as well. I wanted to ask a little bit about, the package mentions that the UL standards contain instructions for the proper disposal of these batteries, which is going to be a growing issue the more of these things we have in circulation. But they aren't specifically discussed or addressed, what those are. So can you explain what we're proposing to require in terms of instructions for safe disposal?
So I think that's a little bit outside of the scope of the NPR as drafted. But I acknowledge your concern. Mary, do you have anything else too?
I don't know, since I'm not the expert on the UL standards, I don't know what's in the UL standards on disposal of batteries, but we can look into it. I know that these rules are really focused on electrical requirements and fire shock hazards, those kinds of things, and not battery disposal, but it's certainly something. I know there are other standards we're looking at. We did an ANPR on the mechanical hazards associated with e-bikes, for example. So I don't know where that properly resides or what's out there, but we will look into it.
I appreciate that. I think it implicates it because, as we're disposing of end-of-life products, we're talking about things that are compromised. We're talking about things that may not have been charged for a while. And so the same fire risks that we have in our homes that we're protecting against we're going to be subjecting people in the destruction chain. So people who are driving the FedEx truck, if you're shipping it somewhere, people who are driving the garbage trucks, waste management facilities. And so I hope we get comments on that. I hope we think about it. And maybe this isn't the vehicle to address it, but I think we should address it. So the rule has a potential to cover a lot of problems. We covered a lot of ground, but we don't address every potential issue we know about. And you've highlighted some of those today, and I just wanted to make it clear that there are still going to be some issues unaddressed by this. And one of those things is detecting whether a battery package contains a defective cell, as you've mentioned, that could spontaneously cause thermal runaway or during, and we see incidents of that in the data. So I just want to confirm that is something that if it's not on the charger where the battery management system could help protect against it, this rule is not going to address against that type of issue, right?
That is correct. There are circumstances that the BMS will not be able to address.
Can I add something to that? Sure. To the extent that it's detected, you may not be able. The system isn't really going to do that. But the standards again are required to have certified cells, which I think goes a long way toward assuring that those are high quality cells that have been evaluated for the proper application and the proper specifications.
Okay, but is every cell certified, or is it certified in batches, or?
Depends on the manufacturer. There's certain requirements for quality control. So you have to test so many cells that are after they're produced. It depends on the quality of the manufacturer, which undoubtedly goes with cost.
Yeah. So I mean, we're not getting visibility into all of them, and we do have these incidents of spontaneous ignition, and so we're not addressing that quite yet. And the other one I wanted to talk about is if someone puts a chop shop battery, and so you could have bad cells, you could have dangerous cells, mismatched cells. You could have no battery management system or one that isn't, designed to operate with the cells that are in there. If they put that into an e-bike or charger that otherwise complies with our proposal, without those protections in place, without the battery management system, with these other issues, nothing in this rule is going to protect against thermal runaway in those batteries, correct?
So I believe like the basis of your question, we can't draw any inference on the safety of that type of system.
Yeah.
That's correct.
Okay. And that's why one of the things that I've talked about and have raised a need for is some redundancies in these protections. I mean, I think we do a great job addressing if you've got a factory battery and a factory charger, making sure those don't cause problems and that they prevent them. But if you've got one of these chop shop batteries, I really like the idea of seeing how protective we can make chargers. And so is there overcharge protection in that? Is there anything that protects against sending reverse polarity to the battery from the charger itself? I would really love thoughts on that if we could develop them through the comment period to make sure we're doing anything we can to protect against those aftermarket alterations that are really cropping up in New York. But overall, I really appreciate the work you've put into this. I thank you for your willingness to talk through it, walk us through these issues, and make sure we can understand them and anybody listening can. So thank you for your work. Appreciate it.
Commissioner Wall?
Thank you, Mr. Chair. I just have a couple additional questions. On page 33 of the NPR, it states that the fatality rates for those under 5 and over 65 categories were disproportionately higher compared to their corresponding proportions in the general U.S. population. Do you have any explanation for this disparity that you could comment on?
For the younger aged, the e-scooters and the other micromobility products, self-balancing scooters, they are consumed mostly by the youth market, so that's not surprising. I would say that would be the leading cause. I don't have any insight to those over 65 or so. We may need to get back to you on that.
Okay, thank you. Are there any provisions in the NPR that would specifically address this disparity?
I think we're trying to treat the system regardless of the age of the user. So I think we're trying to generally, mitigate the risk.
Okay, thank you. I appreciate that. I know Commissioner Trumka sort of alluded to this earlier. I want to come back and focus a little bit though on the many incidents where there are multiple victims, which the draft NPR specifically discusses. And can you provide information on those scenarios? This isn't multiple riders generally, correct? On these devices?
Yes, that's generally correct. From slide 8, you'll see that most of these products are single rider products.
Okay, so that the incidents involving multiple victims are many times victims who have nothing to do with the product. They're in the apartment building, they're somewhere else, and they have no idea that the product is even in use potentially.
That is quite plausible, yes.
In my experience, I could not think of many other examples where such a multiple victim is an issue, where it's usually a one-to-one. There are separate, some come to mind in an outlier example, but I don't know if you all have a comparable example where one product has multiple victims so repeatedly.
I would just add that it's mostly structure fires that are causing the injuries and deaths. So that's probably what that relates to. So because the product spreads to the structure, and then the structure continues to burn. That's what's causing the injuries and deaths and the smoke inhalation.
Okay, so are we taking, and again, I think Commissioner Trumka was driving at this a little bit earlier, are we taking into effect in our analysis of the NPR or our regulatory analysis this potential for affecting bystanders?
You repeat the
Can you turn on your mic?
Can you repeat the question one more time?
Well, I'm just trying to understand if in the actual NPR itself or in a regulatory analysis, we're giving special attention to the fact that with this product category, in terms of victims, it's not a one-to-one, which is more generally the case that I'm familiar with at the commission, whereas the number of victims who have nothing to do with the product are significant. And so I'm wondering how we're taking that into account in this scenario.
Sure. we are not treating them differently, and we're giving each individual life the same value for statistical life, aside from children, which have a higher value for statistical life. But I do believe I'd have to check, but I think it's mentioned in the unquantified benefits that there's the nature of these products. A lot of them being used in urban centers have the potential to cause damage to third parties that don't have any use with the product.
Okay, thank you. I appreciate that. And then one final question. I know the chair asked about the European standard, and I think your answer, Mr. Cadwalla, was that it was inadequate compared to the UL standard. So to me, that would mean we would be seeing more fires potentially in Europe. Do we have data on that?
That I think that would be speculative. It really would depend on what standard is being used as a potential benchmark to evaluate that product, which may or may not qualify as a consumer product according to the definitions within the United States. So I would say that it's that would be highly speculative.
Okay, but do we have data on Europe and what the fire, Mr. Boniface, is?
Yeah, so we did reach over to through our international programs folks to our European counterparts to see if they had rate information. Obviously, what we have, they weren't able to provide rate type information, so we can't directly compare. I would also note that there are some significant differences between the U.S. and European markets, including home construction and fire protection approaches. So it would be difficult to compare on an apples-to-apples basis.
In terms of data, do we have, I think in other rulemakings, we do consider data that's from international incidents. I'm not sure I saw that here, but perhaps I missed it.
Right. We did, again, so we did reach over. We got incident data from the UK and others. But again, for us to be able to factor that in, we were looking for a rate. So that we could look at is the base rate that we use in our economic analysis, how does that compare with the European example? And they were unfortunately not able to supply us with a rate type information.
Okay. All righty. Well, again, thank you. I do appreciate all the hard work. It's an excellent package, and I look forward to moving on with it. Thank you.
Commissioner Ziak.
Yes, thank you. One additional follow-up. Picking up on Alex's question about the low compliance rate for the existing standard. Let's assume for a moment, and this question may be for Ms. House or for Mr. Boniface. Let's assume that some version of this is eventually put in final rule. We adopt these standards either as they are or as modified. That turns us to compliance. And what I also heard is a lot of the existing problematic batteries are imported from China. And I'm wondering, assuming that there is a final rule in place, how are we going to enforce that? Is this something that would look to eventually be suitable to a 15J type finding and rule, or are we going to something that the marks on the product will make obvious either to consumers or to retailers? Can we talk about that a little?
I think this is something that e-filing could help us with, because if there's a mandatory rule, they're required to be tested and certified. So we'll be getting that data coming in electronically, right? And if that's something we want to focus on, we can have our algorithms pointing at these products, these HTS codes, and looking specifically at the data. So that's something that should be able to help us with compliance.
Okay, that's great. Thank you. And would a 15J rule be appropriate in any way on this?
Once we have a mandatory rule, there's probably not a good reason for a 15J rule.
Okay.
And with 15J, the product characteristics have to be readily observable. So the actual thing that's causing the problem, and if you've ever been out to the electrical lab, it is not readily observable. It's a long time. These tests you hook up all these wires. So that's not something we can do at the port. But certificates will be coming in, right? So that's something that we can see electronically and collect that data.
Another advantage of e-filing. Thank you.
Don't believe we have any more questions at this point in time. I do want to join my colleagues in thanking not only the presenters today, but the entire teams that have been working on this for quite some time for all their work in getting us to this point. At this point in time, the briefing is going to be adjourned, and I thank the Office of the Secretary, the Office of the Executive Director, the Office of Communications, the Office of General Counsel, and of course, the Facility Services as well for facilitating today's meeting. We're going to reconvene in about 5 minutes for a closed briefing. So thank you again.